Okay, so we've got a setup here where we're going into the yellow 200 turns transformer into a switch, and then back down we're running at 12 volts DC. We set that up into a 600 turn for an laminated iron core to a 5 watts 12 volt bulb. It has to be low wattage for this experiment to work. And what we're going to do is we're going to turn the switch on, the other side's on, and then turn it off, and we see a spark there. So try it again, and yep, we're seeing spark. Lens doesn't like change, and so we're essentially changing the magnetic flux in that coil and then creating a back EMF. And if you do that fast enough, we're seeing that bulb glowing.
Whoa.
Why does Callum have to be changing the switch?
It's a back EMF thing.
Because we need a changing magnetic
Field.
Yeah, field or flux inside this coil creates a changing magnetic flux, and that coil, which then produces a voltage. So, are these actually touching?
No.
They're not physically touching, so it's true that it's changing magnetic flux. What if I take this iron core off? Yeah, try again. Yeah, we're not seeing that change. And if we use a solid iron core, so we had them on the same side. So these are technically upside down. So we try it again. Now we've got the lid on. It doesn't really work, but we put a solid one on. It works a little bit, and then if we put that on, a laminated one, it's even better. And so there's something different between a laminated core and a solid core.
Yeah.
And if you turn that on and then try and lift that up,
It's quite stuck.
yeah, so you've made quite a strong electromagnet. And then you turn the switch off. It's got a little bit of residual.
Whoa.
And so it's actually creating a permanent magnet when that's on, and you're turning it on and off. And we're also seeing that compass turn, indicating magnetic field. And you can use PhysFox to then see the magnetic field, and so maybe that's the next step.
Yeah.